You've practiced solving quadratic equations using the method of completing the square. Now let's talk about another method, and that's solving quadratic equations in standard form using the quadratic formula. So a quadratic equation in standard form looks like this: ax squared plus bx plus c equals 0. And that equation gives two solutions. We can find those two solutions using our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Now the important thing to remember with this formula is that a does not equal 0. So let's try a couple examples. Okay, this first problem asks us to solve x squared plus 5x minus 6 equals 0. So this equation is already in standard form for a quadratic equation. And we could solve it by factoring, but let's see what it looks like if we use the quadratic formula. So first, let's identify our coefficients. For a, we have a coefficient of 1. For b, our coefficient is 5. And c, our coefficient is negative 6. So these values are important because we can just plug them into our formula. So our formula is x is equal to negative b, which b equals 5, so we have negative 5, plus or minus the square root of b squared, so that's 5 squared, minus 4ac, and a is equal to 1, and our coefficient c is negative 6. So that's the radicand all under this radical sign, and that is all over 2a, and again a is equal to 1. So if we simplify this, let's work under our radical sign first. We have 5 squared is 25, and then 4 times 1 is 4 times negative 6 is negative 24. And we're subtracting that, so let's add 24, and that's over 2 times 1, which is 2. So let me bring this down here. So then simplifying this further, we have negative 5 plus or minus 25 plus 24 is 49, and we'll take the square root of that. So the square root of 49, that's a perfect square, gives us 7, and that's over 2. So then we need to find these two solutions. So if we find the first one, negative 5 plus 7 is 2, over 2 is 1. So one of our solutions is x is equal to positive 1. Or our second solution, we have negative 5 minus 7, which is negative 12, divided by 2 is negative 6. So these are our two possible solutions for this quadratic equation. And again, you could have found that if you used the process of factoring, but this is what it looks like when we use our quadratic formula. Let's try this next problem. It says solve the quantity x minus 3 times the quantity x plus 1, which is set equal to negative 6. Now at first glance, this equation is not in standard form for quadratic equations, so let's see if we can work on this a little bit to get it into our standard form. So let's multiply these two binomials. So we have x times x is x squared, then negative 3 times x is negative 3x, and then we go the other way, so we have x times 1, which is just x, and then negative 3 times 1 is negative 3. And that's all still equal to negative 6. Then let's simplify this equation here. So we still have x squared. We're going to combine these similar terms. Negative 3x plus positive x gives a negative 2x. And then I'm going to add positive 6 to both sides. And so that gives us plus 3 here and a 0 on this side. Now as you see, x squared minus 2x plus 3 equals 0, that's standard form. So then we can find our coefficients a, b, and c for this equation and use the quadratic formula. So our a coefficient is equal to 1, b is negative 2, and c is 3. So then we plug these values into our formula. So we have our formula starts with an x equals and then negative b. So if b is equal to negative 2, we have negative of negative 2, then plus or minus the square root of b squared. So negative 2 squared minus 4ac. A is 1 and c is 3. That's all under our radical sign. And this expression is over 2a, where a is 1 again, so 2 times 1. Okay, so then we just simplify what we have here, and that simplifies to 2 plus or minus the square root of negative 8 all over 2. So then we have a negative number underneath our radical sign here, so we know that we're going to be working with a complex number. So let's go ahead and, let's see, I'll pull this down here. And then we have 2 plus or minus the square root of negative 8 over 2. That will simplify to, we can pull out, we know that the square root of negative 1 is I, and then our factors for 8 are 4 and 2. 4 is a perfect square, so we can pull out 2i from underneath the radical sign, and we have left is the square root of 2. And again, that's all over 2. So then if we simplify this one final step, we divide out our common factor here with 2. So 2 divided by 2 is 1, and that's plus or minus. Then again, 2 divided by 2 here is 1, so that just leaves up top I square root 2. So our two possible solutions for this quadratic equation here, which we put in standard form, are 1 plus or minus I square root 2.